A warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook. Grab a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today, we have an inequality to get you ready for calculus. Now, if you just started Calc 1 or AP Calculus, you'll want to be able to solve inequalities like this with a specific method that I call using the chart. If you're not familiar with the chart, go ahead and take a look in the description. I'll leave a link to a video going into more detail about the chart. If you already know what you're doing, or you feel confident about this problem, go ahead and give it a shot. It should take you only about maybe 5 or 6 minutes. No real time pressure here, but just to give you a sense of the pace. You can pause the video, give it a try. And then when you're ready, unpause the video, come on back, see how we did it here. Alright. Now, one thing that I would like to fix about this problem is that whenever we're solving equations or even inequalities, a great strategy to begin with is to get everything on one side. So what I'm going to do is I'm going to move this expression, which clearly has a negative, over to the other side. That's going to yield 3 over 3x minus 4 minus 4 minus 3x over negative 3 is less than or equal to 0. But if I'm subtracting something which has a negative in the denominator, right, this is basically just going to transform into 3 times 3x minus 4 plus 4 minus 3x over 3. Now we can get a common denominator here by multiplying this fraction by 3 on 3, and we'll have to multiply this fraction by 3x minus 4 on top and bottom. And that's going to leave us with 9, which is very easy, plus I completely expect you to be able to multiply this binomial very smoothly. So we're going to have negative 9x squared plus 24x minus 16. This is all over the common denominator of 3 times 3x minus 4. Or if you'd like to simplify this all, we're going to have negative 9x squared plus 24x minus 7 all over 3 times 3x minus 4, which I guess I could just call 9x minus 12. This needs to be less than or equal to 0. So here's where the beauty of the chart comes in. We need to find zeros for the numerator and the denominator. The denominator clearly has some 0 at x equals 4/3. Whereas the numerator, where does it have its zeros? It has its zeros according to the quadratic equation, or if you wanted to multiply all this out, you could probably find some factors that work here. Let's go ahead and use the quadratic formula. If you know how to factor that, I encourage you to factor it. And if you don't know how to factor it, I also encourage you to try to figure out how to factor it. That way you can just improve your skills overall. But let's use the quadratic formula. That's also something we'll have to be using in calculus quite often. You're not going to get these really nice quadratics that just factor all nice and dandily. I think that's a word. Maybe I'm making stuff up. And then we're going to use our knowledge about the shape of the graph, actually, in order to determine when this quadratic numerator, negative 9x squared plus 24x minus 7, we're going to figure out when that is positive and when it's negative. So let's go ahead and carry this out. It's going to be over negative 18. This all simplifies to be negative 24 plus or minus the square root of 576 minus, 252? Which makes a perfect square, I believe. Yes, it does. It makes 324. That's pretty nice, because that means we're going to have negative 24 plus or minus 18 over negative 18, which is nice. This gives us negative 42 over negative 18, or in other words, 7/3, dividing both of those by negative 6. And we're going to have negative 6 over negative 18, which simplifies to positive 1/3 when we divide top and bottom by 6, negative 6. Now, why are we going to use these? We're going to use these because on the graph of just the numerator, which is a quadratic expression, negative 9x squared plus 24x minus 7, we have some zeros, but we have to remember that because there's a negative link coefficient, the shape of this graph, which reflects the values of the numerator, is going to be flipped upside down in this kind of a shape. And so it's time to bust out the chart. How are we going to use the chart here? Well, we're going to put a number line with our important zeros, 1/3, 4/3, which is a 0 for the denominator, and 7/3, which is the second 0 of the numerator, the quadratic. If you'd like, you can extrapolate from this and figure that one of the factors would be 3x minus 1, and one of the factors would be 3x minus 7. But I think it's a little bit better to just use what we know about the graph, to use the quadratic expression as one row in the chart instead of breaking it into factors. That's the beauty of understanding the graph, is that you don't have to use factors if you understand where the graph is negative and where it's positive. So if we take a look at this, we know that it's going to be 0 exactly at 1/3 and x equals 7/3. But on the left side of that, it's going to be negative. In the middle, it's going to be positive. And on the right side, it's going to be negative, as we see on the graph. Right? Here's the negative space, and here's the positive space. Well, in the denominator of 9x minus 12, we get a 0 at 4/3. We have a negative to the left and a positive to the right. Now, because 9x minus 12 is in the denominator, the overall expression, which is the entire rational expression here, this is going to be undefined when the denominator is 0, and it's going to be 0 when the numerator is 0. And now we can use the chart as follows. So anything to the left of 1/3 gives us a positive. In between 1/3 and 4/3 gives us a negative. In between 4/3 and 7/3 gives us positive. And again, after 7/3 gives us a negative. So if we go back to see when is this going to be less than or equals to 0, in other words, negative or non-positive, that's going to include these points at 1/3, and it's not going to include 4/3 because there's an asymptote there. But we're going to unionize that with 7/3 all the way to infinity. There we have it. Now, a common mistake in a problem like this is to try to take the starting expression. I just want to go over this so that any students who maybe made this mistake can learn from it. You don't just want to multiply 3x minus 4 on both sides. The reason why you don't want to do that is because you don't really know when the sign needs to flip. Remember that the inequality sign must flip whenever multiplying or dividing both sides by a negative. But we don't immediately know when 3x minus 4 is a negative. So multiplying 3x minus 4 on both sides will flip the inequality for certain values of x, and it won't flip the inequality for other values of x. So if you were to maybe not flip something, or you were going to flip something, it's interesting that both of those would just be kind of wrong, because the flips should only occur under specific conditions. So instead, whenever you have an equation or an inequality, I highly recommend to just move everything over to one side when possible. Get a common denominator if you have to. And then the beauty of the chart will tell us when this denominator is negative and when it's positive. That's what this row is kind of indicating. So it captures the appropriate detail that we need. When is 3x minus 4 negative? Here it is. When is 3x minus 4 positive? I think that's enough blab out of me. Like I said, I'll put a video link in the description for the chart so you can become an expert with the chart. And I guarantee you that if you master the chart, your life will be way easier in calculus. See you guys next time.